liftoff of the Atlas V, launching the first interplanetary mission from the West Coast, and NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
And then once we've entered the atmosphere, the drag in the atmosphere slows us down, heats us up, and the heat shield protects us during that time. Once we've gotten down to a low enough speed, we'll deploy our parachute. The parachute will slow us down even more. We'll get rid of that heat shield. That lets us deploy our lander legs, turn on our radar. At that point, we can separate from the parachute, and we propulsively fire our thrusters to slow us down even further, and then we land directly on our legs right onto the surface of Mars.
InSight is the first mission that's going to study the deep interior of Mars. So what we've done in the past is send rovers and landers that really explore the geology of Mars, the chemistry of the surface, what kind of rocks are there. We're going to explore the deep interior and try to understand how active are the quakes on Mars. We call them Mars quakes, not earthquakes. And then we're also sending a probe that's going to drill into Mars about 10 to 15 feet. And it's going to understand the heat that flows from the core of Mars. And so all this information will help us understand, is there a liquid core, a solid core, how did Mars form as a planet? And this will help us understand how Earth, as well as any rocky planet in our universe, formed. So I'm what you call a systems engineer. So I think big picture. There's a lot of experts that are really into one specific part of the spacecraft. And I take a step back and I say, okay, how do all the pieces fit together? And let's make sure that they're all going to work once we're on the surface of Mars. Once the spacecraft lands, that's when a lot of us who have been working what we call the surface mission take over. And so we want to make sure that the spacecraft is healthy on the first few days after landing. So are we getting enough energy from the sun? Did everything survive that big, long journey from Earth? And then we want to start deploying our instruments on Mars. So that's a pretty involved process that involves taking lots of images, doing lots of checkouts. And then the arm that you see behind me, this is going to pick up the instruments that are on top of the lander and then put them on the surface of Mars exactly where we want it to be.
That's perfect. Don't change a thing. Okay.
One of the engineers had this interesting idea that we should shave on the day we launch and not shave again until we land on Mars. I, some reason, accepted that offer, and so there's a few of us that we shaved on the day we launched, haven't really shaved since then, and this is the result of that. I am excited about landing day for another reason, because then I can shave, and my wife will be very excited too.
Power is nominal. Spacecraft battery is fully charged.
I think it was Ranger 7 that was the first successful Ranger mission. We had 6 failures before that. And before the launch for Ranger 7, somebody happened to pass around peanuts. And it was just this kind of random thing. And so everybody had peanuts. And then Ranger 7 was a success. And you don't mess with what works. So ever since then, we've been having peanuts for all launches, and then in recent years, all critical events. So we all pass around the peanuts and make sure that we get that extra little bit of luck in there just in case.